Each week on Tuesdays at noon, solarpvtraining.com hosts a weekly Zoom meeting, and this is really open to anyone. If you want to join us, just contact us through our website, and we'll be happy to provide you with the link for the Zoom meetings. But we do a discussion of solar. Really, the people who participate may have specific projects they're working on, and they have questions about how these projects might work or troubleshoot them. Or we're also just talking about solar in general or what's happening in the industry. So join us for this week's meeting. I wanted to share, on my trip, I became aware of the joys of solar podcasts. So I wanted to share a few of them that I thought were pretty good. And if you're into, listening to solar podcasts, it's a good way to find out what kind of things are on the horizon, both technology-wise and policy-wise. But from a policy standpoint, there's one called the Energy Gang, and that one, Energy Gang, G-A-N-G, like a gang of thugs. That one is quite good as far as talking about regulations and regulators and what's happening in the government and that kind of thing. I really enjoyed another one called Grid Geeks. That one, though, I think may be ending, but that's another good one, Grid Geeks. And
G-E-E-K-S. G-E-E-K-S?
Yeah, G-E-E-K-S, like Greeks, the Greeks shall, or the geeks, sorry, not Greeks, geeks. And there was another one called Solar Mavericks. That one's quite good. It interviews CEOs of solar companies or affiliated companies, talks about their strategic planning and what got them into the industry and what they envision is going to be happening over the next few years. And then there's a couple others that I could mention that I haven't actually listened to yet. One's called The Interchange. One's called Switch.
E-N-E.
Inter like I-N-T-E-R. C-H-A-N-G-E, The Interchange. Then there's one called Switched On. And Suncast, S-U-N-C-A-S-T. So those are worth giving a listen. Of all of them, I think the Solar Mavericks one is the one I've enjoyed the most. And one of the things that it sort of brought home to me, they were talking about solar efficiency and how that continues to go and continues to accelerate. Right now, we're at about, on average, around 20% efficient for silicon, but they're beginning to integrate perovskite with silicon, putting tiny layers of perovskite over top of the silicon. And they were really projecting that really within a few years, 5 years, 10 years, we'll be seeing 30% efficiencies. And I've always kind of discounted the efficiency issue because it really doesn't matter how efficient the panel is unless you're lacking space on your roof. What really matters is the dollar per watt cost. But what they were pointing out is the more efficient the panel gets, then the greater the reduction in all of the other balance of systems costs. If you're putting 8 panels down instead of 10 panels, well, you've just reduced 20%. The racking size, perhaps combiners, the labor that's involved, a lot of those kind of aspects. So even though solar panels are only about 16% of the cost of an installation, the more efficient they get, then the more the other costs come down as well. So again, a change from 20% to 30% is 50% increase. You can get by with a significant smaller number of parts.
And it's besides the expense, there's the environmental there's the environmental aspect, the embedded energy. So you cut it down 20% and you have 20% less aluminum being
Sure.
mined and refined.
Yeah, and the aluminum, of course, silicon has its cost and environmental cost in harvesting. And silver, apparently all of those little contacts on the panel, on the front of the panel, are silver. So I was wondering what all of this GameStop stuff is going to do to the cost of silver and whether that's going to impact solar at all.
It's like the Hunt brothers.
Yeah, I remember back in school when they did that, where they tried to corner the market. In fact, the big joke there was, how do you make a small fortune in Texas? Start with a big one. So, because they managed to lose their shirt. Speaking of losing their shirt, I think this is a watershed moment here. 2020, Tesla posted over $300 million in profits, and Exxon lost $22.4 billion. So first year in their corporate history, Exxon lost money. So I think that's a sign of things to come. We're definitely
How much did they lose? How much did they lose?
$22.4 billion. Exxon did.
So I have oh, sorry, go ahead.
I was going to just joke that that's probably the bonus they paid their CEO.
Yeah, that's right.
Go ahead.
Is there a particular agenda? I had a question. I didn't want to interrupt anybody though.
No, yeah, go ahead and jump in there. I just had the podcast, but then William, I think you had a question as well. So Vince, why don't you hit us with yours first?
All right. Well, I just started up a system up here in Vermont on Friday. Thing is awesome. Started up. Everything worked perfectly. The battery integration was perfect. Anyway, but I'm producing about 4 times as much power as I need. So we have an old oil-fired burner that I want to replace with a heat pump. And I looked at air to water. I mean, this is kind of outside of the scope of solar, except that it's an application for excess production.
Uh-huh.
So air to water and geothermal and or ground to water, I guess. Anybody have any specific suggestions? Ground to water, I think we have a real problem with ledge here, so I don't think off and on you can't dig more than a foot down, so it seems problematic unless you pile a bunch of dirt on it. Air to water seems pretty good if anyone has any specific brand suggestions like LG or Arctic or anything.
When you say, you said you dig down and you have a problem with what at your location?
Ledge.
Ledge.
Yeah, that's not a problem in Ohio. Ohio
ledge is like a granite, like
yeah, it's just it's when you basically hit the hard surface of the earth.
Yeah.
Beyond the dirt, beyond the biome or.
Yeah, we have shale issues and things like that, but not something that can't be overcome. I have seen geothermal run through ponds. Is that an option? You run the coils through a pond.
Yeah, we have a pond, but it's about 200 yards away, which starts to make it a little problematic with insulation and stuff. So. Yeah.
And you're saying a conversion like a heat pump almost, for the air using.
Yeah. Well, the ground to water exchanger is about, I can't remember what the multiplier is, but it's around 3.5 to 4. So every watt you put in, you get 4 back. And at low temperatures, which you get up here a lot, it's for air to water, it can go down as low as 1.8 or so. So
yeah, because I thought those only worked in warmer climates. The air.
They go down to minus 25 right now. LG and Arctic. Oh, sorry.
So don't you have wells out there?
Yeah, I mean, we could do it vertically too, but I'd have to drill a whole bunch of holes, which is, means bringing in a drill rig, and there's no groundwater. It's not. It might be 40 feet down.
Yeah.
That it might work, but it's a lot of. I'm trying to minimize the disturbance and the site development.
Well, is the purpose of doing this just a general energy efficiency thing, or is it that you've got a lot of excess solar capacity and you just want to use it up?
I want to stop burning oil. Speaking of Exxon, I want to hit their profits even harder.
Uh-huh. Yeah, I just was wondering if you've got so much extra capacity, even in the winter, whether electric heat is an option. Just
it is an option. It's just the heat exchanger is actually 4 to 6 times as efficient as a resistive heat. I mean, I could put it like a big tank in and just put a resistive load in there and keep the tank as a buffer because we have radiant heat. Keep it as a buffer for the radiant. Just put a thermostat on it with a controller. But it's more that almost feels like I'm just using it to use it rather than efficiently use it.
Yeah, you're right. Although we're finding.
Original take.
Go ahead, Bob.
My original take on doing this is to first reduce your need for energy, and that's by going to a super insulated house and having air exchanges that if you're going to have a furnace or something like that, that the air you're sucking in, I would hook up to the outside air. Fire doesn't care if it's burning minus 200 degree air or 75 degree air, but if you're going to be putting air out, somehow you can put it through air exchangers too. So you start out with a very low demand, then all of a sudden the formulas start becoming easier.
Right, which is, and you're right, and we've already done all that, except for the minus 200 air would actually be liquid. I'm kidding.
Or it would be Chicago.
Don't do that.
Chicago on a nice day, right?
Right.
Don't do that. Don't do that then.
Okay. Well, William, I don't know that we're going to be able to help you. At least I'm not going to be able to, as far as it sounds like you just do your research on that. But that's a good problem to have, that you're generating a lot of excess capacity.
Yeah, and we get net meters, but it expires after a year. I mean, the credits expire, and there's no payment for production. So.
But
I still would drill well.
You can still zero out.
I still would drill well.
Yeah. You can still zero out.
Zero out, and that's why I'm, maybe get an electric car and put a charger in. That'll help too.
Yeah, I think
balancing act.
I was surprised with the electric vehicle because we got one last year, and I really thought that would significantly increase our electric consumption. But really, as it turns out, even if we fully recharged it each day, it's just 7 kilowatt hours per day of capacity. So that was, considering the average home consumes 30 kilowatt hours a day, it's not going to, it adds to your load, but not significantly, unless you're driving, hundreds of miles a day, which would become a bigger issue. But in which case you just drive to a local place and plug in there without them noticing,
Right.
like using their Wi-Fi.
Right.
So, all right. Well, William, you had a project that you were involved in or on the sidelines on.
Yes, I was contacted just because I'm give my services away free. So someone in Navasota, Texas has got a huge array, and I'm going to share my screen. Can I do that?
Yeah, sure.
Yeah. Let me see where. Okay. So here's a picture of the array, and I don't know the panel size, but I estimate between 36 and 43 kW, depending on the panel size. And let me see whether I can find the next photograph. I sent them to you. I'll stop share on that. And let me see. And I sent some pictures. Let me see. How do I kill that? Oh my. Go to my
Yeah,
desktop.
I took a look through those pictures,
Yes.
and it's a significant system for sure.
It is a significant system. Are you seeing this? Oh no, I'm not. Let me share this one. This, I believe, is an Outback Radian. Does that seem logical?
Let's see the picture. Yeah, those are a couple
Is
of
it up?
what that looks like to me anyway. You've got the Outback charge controllers on the right, which is a good. It's an MPPT charge controller. Probably I'd have to look, but the newer ones go up to 600 volts, but their most popular goes up to 250 volts input. And the thing on the left there is probably just a cable management area, you know, with your disconnect switches and your breakers to make your connections into your batteries.
Well, if I stop share and do another picture, let me do that. There appear to be two of those. Let me, yeah. Okay, I'm going to share screen again.
Okay.
Appear to be two of them. Then you can see a lead acid battery bank.
Yeah.
Those look identical left and right up on the wall.
Right.
Some of the problems that I've been told about, number one, they have some standby gas-fired generators, and when the lead acid battery gets to 50% depth of discharge, they want to turn on the generators, and for some reason or other, that data is not available to cause the generators to come on.
Yeah.
You know, in other, you want it to be just happen automatically. I don't know how many batteries that is. I may go visit this place tomorrow. And
Yeah,
then
you
in
can't
another
really
photograph,
tell if
there's
you can't tell if there are two layers of those or if they're long thin batteries, but clearly there's at least 4
well, they are
strings and there
long
might
thin,
be 8
but
strings. So
yeah. And there's at least 3 or 4 SMA inverters, and I'm not sure of the wattage. I wish I could scroll through the photographs. Well, maybe if I do see all photos, no, that doesn't work. Well, I'm going to stop share. What, Jay, I've already indicated to these people that this is above my knowledge area, and that they're looking for someone to, apparently they've gone through 4 contractors trying to make it work, and I don't know whether it's working yet. It may be working, but they're not, so what they're looking for is help, and they also indicated perhaps find someone that can maintain the system. This is sort of bordering on commercial, given that it's a large array. And
yeah.
the owner, I don't think any of the owner's representatives are on this call now. I see Tony and Ryan.
No, I
the
recognize
owner,
everybody.
okay, the owner is really, he couldn't even tell me the size of the array. So he's not involved particularly, except
He's
for
disconnected.
paying the money. Huh?
He's disconnected
He's disconnected
from the array.
Right. But anyway, I thought, and in fact, I got a telephone call from the last contractor that seems to be knowledgeable about what the problems are. And he couldn't get on this Zoom call. He tried, but apparently when I forwarded him the link, he couldn't do that. So I was hoping, Jay, that I could perhaps have you connect with him on another Zoom call or something like that to brief you on the scope of the problems and see whether you might have any suggestions.
Sure. Well, let me, I'm gonna try and draw a picture of what I think we're dealing with there. And you can tell me based on what I saw. So you've got a solar array, and as you said, it was quite a large one. You said, how big do you think it is?
36 to 43 based on 250 watts or 300 watt panels.
All right. And that's coming in, it appeared in 4 strings going into the, to 4 different charge controllers.
Okay.
Okay, so, and that would be based on, you know, and those are going to be home run all the way to the charge controllers. And then
I'm with you.
they're combined, leaving, going, I don't, in that, probably with a breaker or a fuse in that box. And then they're going to 2 big battery banks that were in those cabinets that are there. And then each of these battery banks is going to a Sunny Boy inverter. And from there, then of course, it's going to be 240 AC, I assume, unless it's a three-phase system. You said, is this a residential or a commercial building?
It's residential, but you know.
Yeah.
Yeah.
Okay, and here, there's probably combining them in an AC disconnect of some sort.
Mm-hmm.
And then from here, my guess is it's going to be a supply side connection. And then here would be your
Could you
service.
elaborate on that?
Yeah, because normally you would come into your service panel, you know, your breaker box, and that's where you'd make your connection for your solar array. So you would just come down in and go into a double pole breaker somewhere here. But this system's much too large for any residential service panel box. So they will have had an electrician come and make a connection somewhere between the meter and the main disconnect. So this would be the household main. So they're just tapping into this power line, the incoming line from the utility. And so now you're feeding in, and of course, if the loads need the power, it's going to flow that way. If they don't need the power, it's going to flow out onto the grid. And this is referred to then as a supply side or a line side connection.
Okay, yeah, I'm with you.
And
Is that small square box where after the AC disconnect, is that strictly, there's no breakers or anything in there?
not normally. It's just often is just a tap. You know,
Okay.
they even have them where it just pierces in through the insulation, but I don't like that kind. But often they'll come in, they'll break it, they'll terminate onto a bus bar in a box, and then they'll just come in and connect to that same bus bar, you know, with a bolt or whatever. But in order to make a supply side connection, you got to have your power disconnected at the meter or at the transformer. So it's a more expensive way of making your connection, but it avoids the issue of violating the 120% rule, you know, of coming into your service panel. Because
Gotcha.
even on 200 amp service, which is fairly common for residential, that means you can only come in with 40 amp. But if we look up here, and if you've got basically 40 amp maxes out at around 11,500 watts, or 11.5 kW system, is about the biggest size system you can load side connect to a residential home. So this is 3 to 4 times that size. So we're probably looking at a supply side. I would almost guarantee it. Now, this is fairly straightforward. Yeah, it's complicated, but it's fairly straightforward on how they've done it. And these things just, it would be the same as if you had a smaller array hooking into a charge controller, hooking into the battery, hooking into an inverter. But because the charge controller is too small to handle everything you want to feed that inverter with, you've got two of them coming in, and they just combine in that box and then feed into that battery bank. And then from that battery bank, well, now you've got two inverters because they're too small to handle the whole array. So you've broken it into 2 bits. Now from there you can combine them because now you're just increasing amps. You know, the power is going to be the same signal, the same strength. It's getting its reference from the grid, so you don't have any harmonics issues. And then you'll just hook them together and make sure your wire is big enough. So from that point forward. Now, the tricky part, you said, is now they want to integrate a generator over here, and they want to somehow go ahead and charge these batteries if the battery bank goes down. And so these are definitely an island, these would have to be, I assume, I haven't looked at those inverters, but I would have to think they're bimodal.
And
Otherwise,
bimodal,
otherwise
bimodal mean?
they would disconnect from the grid if the grid goes down and then tap into the battery bank. You know, with a bimodal inverter, normally I'll draw the inside of the inverter here. And typically then what you would have is, well, let me think now. If we're doing that, we would have to have.
It's got to go to the panel.
Yeah, it's got to go to a sub panel before it goes to that AC disconnect. So somewhere in here, you've got to have a second sub panel. And then you've got to have another AC disconnect before it goes to the tap. And then this sub panel's got to be connected in. No, you don't want it connected in. All right. So
I'm a little bit confused about the rapid shutdown in this circuit.
the rapid shutdown?
Yeah, how's that work?
Oh, it doesn't, but it's a ground-mounted system, so it doesn't need rapid shutdown.
It's still got the anti. Oh, sorry.
Yeah,
But
it
if you
has
hook up to the
anti-island.
grid,
Yeah.
but if you hook up to the grid, you're going to have rapid shutdown.
No, you're confusing, I think, anti-islanding with rapid shutdown. Your rapid shutdown
I always
basically
do
means it
that.
turns out at the panel. Yeah, so what you end up with is, I'm trying to think here, there will be another trying to think how you would do this.
Do they want the generator to just charge the batteries? Do they want it to provide power to the house too?
I've been told when the batteries get low, 50% state of discharge, that the generator kicks in. This is a 100 kW generator, oddly enough.
Yeah.
That's what I've been told.
Normally what you would do is for a system, and I'm just wondering how you do it with these two inverters, but normally what you have is you hook your generator and there's a port within the inverter, and these inverters are referred to as inverter chargers. And what they do is the inverter takes care of all of the electronic signaling. Since it's connected to the battery, it's checking the state of charge from the battery as well when it's in isolated mode. And it will send a signal when the battery depth of discharge reaches a certain level to kick on and feed the battery, but it can also determine it can feed the loads as well. So all of that intelligent electronics is in this inverter, but it has to be an inverter that's designed for that. So whether those inverters, you know, I'd have to look at the specifications, because not only are these things going to be bimodal, meaning that they can go from grid tied to standalone, but they also have to be an inverter charger, which means you can integrate an inverter into that unit. And I don't know how you would hook up one generator to two different inverters, or even if it's necessary. But I'm sure there's a way, you know, there's always a way. Question
You
is
could
how
split the-
expensive, you know?
Split the sig. Yeah. Well, I mean, one voltage signal will go to one inverter for one battery bank, and the other one would go to the other one. So, you know, rather than having them both go. Oh, I see. Yeah. So, what about like a Solarc is bimodal, and that's what I installed. And you can, you know, you got the wires. It's got the generator signal coming right out of there. But you're right. It's for both battery banks.
Yep. Another thing that could be an option is, of course, they do sell battery-based inverters. You know, and you could add a third inverter to this and have that just there to handle the generator and the batteries. But that seems a cumbersome solution. I don't, you know, it's, let me clear this out.
Two generators.
Yeah, you could have two generators, but again, that feels cumbersome.
Clunky.
Normally what's going to happen with a system, let's assume just one, you come in here, you're going to have your charge controller, then you're going to go to your battery bank, then you're going to go to your inverter here. Then from your inverter, it's going to go to a sub panel. I'll put that as because it comes in as the main on your sub panel. And then it's also going to go and hook in to your main panel. And then this is your main, and that goes out to your meter. All right, so this is typical. Now, if you want to hook in a generator, you would just simply connect that in here, and it's just like a secondary power supply, just like your array is.
So you're saying that the generator is DC then?
No, it's AC, but that's taken care of in your inverter. That's why they refer to it as an inverter charger. So it will take that AC power, and it can just pass it straight through to load, or it can convert it to DC and charge the batteries. So
if the inverter had an integrated charge controller, then you just the power would go directly to the inverter.
Right. And it would have to be an inverter charger.
Right.
I don't think I've ever seen charge controllers that are designed to hook directly to a generator. But I've seen a lot of inverters with generator ports that you just simply hook in, and it's all internally designed. So this is a fairly straightforward system. But the question is, okay, now you've added a second one and a second generator. You know, you could duplicate this. Now, what happens is, let's say the grid is functioning, the grid's operating, power is coming from the battery or from the array through the battery, and it goes into your inverter. It's converted into AC, and it travels to the sub panel and the main panel. So it branches off and it goes in both directions. Now, your generator would never kick on when the grid is operational, because the grid supplies whatever power. You're never going to drain your batteries down pretty much below full load. But let's say the grid goes down. Well, then what happens is this connection here, I didn't want to erase the whole inverter. I just wanted to erase that. All right, so that the connection between if this is your inverter, the connection to the grid disconnects, but this one remains open. So there's that relay switch within the bimodal inverter that disconnects you from the main. Okay, so now only your sub panel is live. You are now disconnected. There are sensor wires that continue to check to see if this grid connection reestablishes itself, but you are physically disconnected from the grid. Now, there are also sensor wires that is looking at the state of charge of the battery bank, and if it senses that the battery bank dips below a certain level, it will send a signal to the generator will kick on, it will send power to the battery, and it can also send power to the loads. So all of that's handled internally within the inverter.
Wow.
So that's the way typically you would see a grid interactive system with a generator integrated, how that would be established. But because your system is basically 2 arrays hooked up together, don't quite know how you do that with just one single generator. And do you need to? You know, is it required? Because really, if your generator is just dealing with one of the battery banks, and if it can continue to feed it through to the load, then do you really care? You know, it's only going to recharge one battery bank, but it's going to service all of the load that you need serviced.
Okay.
Does that make sense, William?
Well, it makes sense, but I have to say that this is above my skill. I've never experienced all this stuff before.
Yeah, and
what
one of the issues that we're going to be facing here as solar installers, even at the residential level, is this is getting to be a much more common thing. You know, AC coupled systems and DC coupled systems, which is what we're talking about here, were fairly rare until really the last couple of years. Now Vince is already talking. You've got that Solar system, right? Isn't that a DC coupled system?
It's DC coupled. Yeah, and I have a 18.5 kilowatt hour Fortress battery. So yeah, that's what the storage is.
Is yours set up very similarly to what I'm showing here?
It is, except for the charge controller is integrated. And there is a generator port, but I'm not using that. There's a critical load port, and I'm hooking up the sub panel tomorrow. But it's very similar to this.
And even though the charge controller may be integrated in the same unit or in the same box, logically the connections are being made this way. Your array is connecting to the charge controller, and then the charge controller is being connected to your battery, and then your battery is being connected to your inverter. Even though all of these connections are taking place in the same box, this is the logical layout of that system. You know, it has to be, because of course the charge controller does nothing but controls the charge from the panel to the battery. So it has to come first. So that's why those pictures that you had, William, showed that big wire management box, because there's a lot of stuff, a lot of cables that have to be managed in there.
I have a hunch that box is much more than wire management. I may make a trip out there later on, and maybe I can have you on the line or Zoom with you. Maybe they would allow me to remove a cover or get a brand.
Sure.
And have more information. Again, they're looking for someone who's smart in this. As I mentioned, they've had 4 contractors come and go, and I presume they threw up their hands and said, no, this is too complicated.
Billable
Well, there you
hours,
go.
Jay.
There you go,
Yeah,
Bob.
right.
It's a job for you. Just head on down to Texas, right? So it's really not, it's not that complicated a job for people who have done those kind of installations, obviously. I always like to say brain surgery is easy if you know how, so
Yeah.
so every job is easy once you've done it a few
Yeah.
times. So
Yeah.
I'd like to step in here for a second for clarification.
sure.
The way I would design a circuit is that I would come off the solar panels, go through the inverter, go into the box with standard stuff to a grid tight system. Then I would I would have the electronics to charge the batteries and keep the batteries charged. And then when and if we lose power, then the batteries would kick in, and you would get that. But what I'm seeing here is that they're going right through the batteries that's straight out into the circuits, and that's sort of like confusing to me at best, because you're just going to keep cycling your batteries all of the time.
No, actually it doesn't. If you see here, this system here, when the grid is functional.
No, I agree with that system. It was the first system you were talking about.
Oh, yeah. Well, that's, of course, the issue there. It's basically 2 of these systems. Everything's the same, except if we come down, there are 2 charge controllers because it's too big, and they're going to go and connect together somewhere in that wire management. So you've got that. So this is kind of one of your systems, and then duplicate it. And then the question is, how do you hook into the grid? Because now you've got a double system like this. So how do you do that? Well, you can't do it load side because it's too big. So we got to do it supply side. But then how do you integrate in a critical load if you're doing a supply side connection? Well, I mean, in theory, we could do that. But again, we've got to have 2. We'd have to go here to this panel, and then this would connect up here with an AC disconnect. I was using my mouse for that. I should use this stylus. So AC disconnect here, and then you're no longer connecting into your main. So this would be your supply side connection, but you'd still have to have a critical load box.
You really need to see like all the components. I mean, are there 2 line side taps? I mean, are there 2 panels? I mean, because this would require at least 2 200 amp panels. Is there a 400 amp or 600 amp panel? Does it combine in the, do they both combine it?
Yeah,
I think it was mentioned that there is a 600 amp service.
Okay. So
yeah, if there's
combine in the
600 amp
service.
service, well, then you might be able to go into a load side connection, and you wouldn't have to do the supply side. But there would really be nothing to prevent you from coming in here. Let's say this is your other inverter. You could take this from here and connect in here and make the same supply side connection. As
if
long
it's
as
big enough. Oh, sorry.
Yeah, as long as the wires are large enough, to accommodate everything.
If the panel's big enough, you have 2 200 amp breakers going to the bus bars, and then have the main 600 amp disconnect, and then you have 200.
Well, you wouldn't even need to worry about that on the bus bar here because you're never entering the bus bar except
Right.
for your load. Whatever your load is currently drawing. So it would have already been sized appropriately. The only real size issue is how much are you pulling into your sub panel?
I calculate the panels are putting out 160 amps at 240.
Yeah. So if this is a 600 amp box, well, if we're going with the 200 the 120% rule, you could come in with 120 amps, you know, load side connected. But you could do even more if you were to say, get rid of that main breaker, assuming it's a 600 amp breaker, and put in a 500 amp breaker. Then we could go up to 220 amps coming in from your array. So there are ways of manipulating that.
So there's no real there's no advantage to running through the main panel, I guess.
The one advantage typically is it's cheaper, you know, but this seems like money is no object kind of installation, you know. It's not going to be cheap however you do it. So I'm not quite sure, you know, like you said, I think, Vince, we'd have to look at all of the components. We'd have to do a complete site assessment to just find out what size breaker, is there room in the main, what is their load capacity for their critical loads, you know, what have they determined on that? Do they have a single critical load panel, or do they have dual critical load panels, one being fed from each of the inverters? You know, how is that all working? So,
well,
we'd have to look at that.
If there was only a book that had all of this in it,
yeah,
life would be a lot simpler.
yeah. Oh,
The book's great.
speaking of that, I went ahead and I put a note in the announcement today, and I'm going to ask each of you guys, if you would, to go into Amazon. I put a link in there, but I'm trying to raise the profile of that textbook in Amazon. So if you could do some sort of nice review. If you give me a crappy review, I just assume you don't go in. But if you give a nice review, it should help promote the textbook, because it was very disconcerting when I did a search on solar textbooks in Amazon, and it wasn't until like page 4 or 5 that mine finally showed up, which is not good, especially since most of them that came ahead of me were written in 2004, you know, 2011. So I'd like to push, and I assume that's one of the metrics they use is reviews, evaluations, you know, ratings, things like that. So if you could do that, that'd be great.
It's a really comprehensive. So how long? Huge amount of work. How long did that take you to get the final draft?
Well, this is the 8th edition, so it's really the 8th time I've gone through a complete revision of it, and so it's hard for me to really judge. But with this last update, I would say it took about 2 months to sort of do the last rewrite. And in the last rewrite, I ended up adding about 100 pages. So, and I should point out Ryan, who is in the middle of my screen anyway, Ryan Evans, he's actually designed and created the cover for the textbook. So he's our resident graphic designer.
All right.
When he's not designing underwear for Walmart or whatever it is that you do, right?
Can I ask a question?
Sure.
Yeah. The subject of rapid shutdown on off-grid systems, it's required, I believe, in Houston. And the only product I'm aware of is called Fire Raptor for rapid shutdown. And I was wondering whether there are other products that anyone is aware of.
The Midnight Solar, Tygo.
Yeah, there are 2 different rapid shutdown issues for standalone systems. One is shutting down the panels on the roof. Now, bear in mind, rapid shutdown for your panels only applies if it's a rooftop mounted system. So if it's a ground mounted system, that's not an issue. But Tygo, of course, is the main supplier of rapid shutdown electronics that work with string inverters and any number of solar panels. So that's sort of the go-to if you've got like the Sunny Boy string inverter like you had in this system. If you're using microinverters or Solar Edge. Of course, the rapid shutdown is built into the electronics that are part of that system, the microinverter and the like. But the other thing with a standalone or grid interactive with batteries is disconnecting the batteries in case the first responders arrive. Because, of course, the whole idea of rapid shutdown is as soon as they disconnect your system, they want there to be no electricity within that structure so that when they go cutting through walls and whatever, they don't get electrocuted. But your battery backup system's designed to avoid that situation. Soon as the grid goes down, now you got power. So they typically have a rapid shutdown button or disconnect that is either hardwired to your battery bank or wirelessly operated that has to go out next to the meter as well. And I think Vince, is that Midnight Solar has one, I think, for that particular.
Yeah. Well, they have one that works with its combiner box at the array. And
Yeah, that's a different issue. Yeah, these are sort of disconnects that attach to your battery bank. They're essentially a DC disconnect. And what happens a lot of times, and these are usually affiliated with the inverter, so that it turns off at the inverter, shuts everything off, including the batteries. But often in some places, like in California, they just simply locate the inverter outside, right next to the meter. But in a lot of our climates, that's just not a good option. So you've got to have.
It's really weird.
Yep. Go ahead, Ryan.
You just have like a shiny, nice piece of hardware like outside of someone's house. It looks, like their cases make them look like Tesla Powerwalls kind of, and it looks like really attractive, and people just have them outside their house.
Yeah, I've always thought of with a set of bolt cutters and a pickup truck, I could go and find myself some really nice inverters, So,
or it's a conspicuous consumption. They could just get the cases and put a dozen on the outside of the house.
Yeah, but they do have these things, and they are basically a remote disconnect switch, which you'll need to put in. But what we find is most electrical inspectors are not aware of this provision, so they don't necessarily require it. And most people putting in your own standalone system are usually kind of off-griddy. They don't like no stinking rules anyway, so they often don't comply with these rules. So, but it will add a significant amount to the cost, somewhere. But I'm just guessing, but I would guess $500 to $1,000 for that disconnect switch. So I know in the last edition of the textbook, I did some research on it. I think I've even got a picture of the product that's there for the battery disconnect. But just bear in mind, you've got to have two different shutoffs, one to shut off the power at the panel and another to shut off the power at your battery bank when you incorporate batteries. Hopefully that didn't confuse everybody. So. Any other questions? Okie doke. Well, we'll schedule again for next Tuesday. Yep. And William,
let me ask a question. William or Bill?
Okay.
But
right.
I may go out and visit this array and try to understand what's there. And I'm just wondering whether it might be a useful discussion for next week's event on Tuesday.
Yeah, that'd be nice. It's nice to have a real world project to kind of look at and puzzle through. And if you want to Skype me in or Zoom me in on something like that based on availability and internet connectivity, I'll be happy to kind of look at it. I don't know how much help I can be, but I can try and be some help.
Okay, I'll try to arrange that with the owner and take pictures and try to understand. You know, I had a conversation with the owner's electrician today, and this is an electrician, not so much a solar person. You know, that's part of the deal, right? It is electrical in nature.
Yeah.
So yeah, I'll see whether I can arrange that thing and inform you, perhaps, so we could talk about it next Tuesday.
Okay. All right, that's
Thank
great.
you.
So we'll all be back here Tuesday at noon. Yeah, Bob.
I just want you to know that based on what I've saw here today, I'm going to start a collection of solar designs not encumbered by the thought process. So if you see anything like that, let me know for
Okay.
my book.
Most of my designs are
Like that.
unencumbered by the thought process. So I'm always amazed when they work.
Yeah, mine are impeded by the thought process.
Yeah, overthinking it. Okay. Okay. All right. Well, we'll see you all next week.
Thanks. See ya.
Bye-bye.
Thanks, Jay.